All right, so this is also in Unit 1, Transformations, and it's the topic on writing equations from graphs. So in the previous video, we had equations or functions and we graphed them. Now we're going to do the opposite. So given each graph, write the equations based on the transformations of the parent function. So of the parent function, so your first goal is to figure out what is the parent function. And for this one, hopefully you can see that it is y equals x cubed. Okay, we have the odd relationship. It's monotonic, which means it's always increasing or decreasing. So we have an odd function here. So it's odd, which can help us see any transformations that are occurring. For odd functions, there is a type of reflection here, but for odd functions, you can use a vertical or horizontal reflection. Because it has that odd relationship, you can use either one. I'm going to use the vertical for this first one, okay? And then something else that we want to look at is the center of this. Is it shifted up, down, side to side? The parent function, it does pass through the origin. It's increasing through the origin, but we already took care of that with our vertical reflection. But this one is still in the origin. So I don't have any vertical or horizontal translations. Next, I want to see, are there any horizontal or vertical dilations? If I look at this here, I can see that this has a distance of 2 units. My parent function, it's usually -1, 0, 1. So it has a distance of 1 unit. But this one is being dilated by 2 units. Horizontally, it's the same. It's still 1 unit. But we have a vertical dilation by a scale factor of 2 units. All right, so we took care of our reflections, translations, and dilations. So that means for this one, if we want to use the vertical reflection, it's going to be y is equal to -2x cubed. If you want to use the horizontal reflection, that's going to be y is equal to 2 times -x cubed. And if you see, these are equivalent based on if we were to multiply the negative out, but either one is acceptable. All right, this one. The parent function for this one, you want to look at the actual shape of the graph itself if you were to remove all of the transformations. So yes, this is an absolute value, but the parent function is going to be the quadratic. So we'll have y is equal to x squared. Y is equal to x squared. So with this one, we can clearly see that this one's it's been manipulated. This one should be going in this direction if it did not have any transformations applied to it. So we obviously have a vertical reflection, but a negative, just putting a negative is not going to satisfy this. Therefore, we have to use the absolute value of this function because every single negative value is being reflected over the x-axis. So my suggestion for this, technically you could use this as the parent function, or you could use this as the parent function. If you use this one, where the parabola is facing downward, you have to use another reflection on top of your absolute value. So I always suggest use the parabola that's facing upwards because that's one less transformation that you have to worry about, okay? So my vertex, if my parabola was facing upwards, is going to be here. My HK is going to be at 1, -3. Clearly it's up here in the picture, but that's after the absolute value has been applied to it. if I did not have this absolute value with my parent function, my vertex would be here. So because my vertex is equal to 1, -3, we have a vertical translation of -3, because for the parent function, it should be on the origin, so it got shifted down 3. And then we have a horizontal translation of 1, because when it started here, it got shifted over 1 unit to the right. Now, based on the key points I see here, they are still separated by 1 unit. So that's 1 unit vertically, and then it's also 1 unit horizontally. So there's no vertical or horizontal dilations. So if we were to write this out, we have y is equal to, all of the values are going to be positive. All right, so that means everything is inside of the absolute value, including the y's, or the y transformations. So we have that horizontal translation of 1 to the right, so it's x minus 1, and then squared, and then that vertical vertical translation of -3, so we'll have -3. Now, you could also write it, if you wanted your parabola to face downwards, you could also write it as this. Y equals the absolute value. That downward, if the parabola was facing down, that means you have a vertical reflection, so it's going to go on the outside of the parentheses. +3. So that's what it would look like. This is if your parabola is facing upwards, and then you apply the absolute value. This is if your parabola is facing downwards, and then you apply the absolute value. Either way, they're both going to end up looking like this. Because in this first one, we are flipping the vertex portion down, and the second one, we're flipping the tail ends up. So they'll both always end up looking like this. All right, example 16. This is an exponential function. These can get a little tricky, so we always tell you what the base is, all right? If we tell you the base, that's going to be your parent function. If you do not see the base, that means it's going to be e. So the parent function for this one is y is equal to 2 to the power of x. And then sometimes people get confused, is this log or exponential? Well, because you'll be given the base if it's log as well, but the giveaway should be which asymptote do you see? If it's a horizontal asymptote, then that means it's exponential. If it's a vertical asymptote, you have a logarithmic function. All right, so a couple of things with this one. If we think about our key points for exponential functions are going to be -1, 0, 1. And if we plug these points into the function, 2 to the power of -1 is 1/2, 2 to the power of 0 is 1, 2 to the power of 1 is 2. If we look at this, well, first I'm going to look at the translations. Do we have a vertical translation? Yes. We can see that our horizontal asymptote has been shifted up 2. So that means we have a vertical translation of 2, or you can say 2 or just 2 units. Now the next thing I want to look at, are there any horizontal translations? If I look at my table, I can see that the parent function, the middle point, should be passing through the y-axis, okay? Because x is equal to 0, that value of 1 should be passing through the y-axis. But if I look at this, my middle point is not passing through the y-axis. That means this has a horizontal shift, and it's going to have a horizontal shift of 1 unit. Or horizontal translation, sorry. So horizontal translation of positive 1. And then for dilations, I can also use my key points. So if I look at my horizontal, it has a distance of 1, distance of 1. If I look at this, my points have a distance of 1 as well. So there's no horizontal dilation. Vertically, I can see that this has a distance of 1/2, this has a distance of 1. If I zoom in, I can see that this has a distance of 1/2, and then this has a distance of 1. I'm looking at these points here. So these are separated by 1/2 unit, these are separated by 1 unit. So there are no dilations, vertical or horizontal. So this parent function, this transformed function, we have a base of 2, we have a horizontal translation of 1, so we'll have x minus 1, vertical translation of 2, so we'll have plus 2. And example 17. So example 17, this can be confused for a logarithmic function, but there's two things missing actually. We don't have a horizontal asymptote, and we did not give you a base. Because there's no base and there's no horizontal asymptote, this has to be only one other function, and that's going to be your square root function. So y equals square root of x. The giveaway is this start point here, okay? We don't have any asymptotes, so we want to focus on that. Okay, so a couple of things. Your parent function, this does start at the origin, okay? So it's on the y-axis, which is good. We don't have any horizontal translations, but we did move it down 1. So we have a vertical translation of -1. All right, so we have no reflections. We checked our translations. Now I want to check for dilations. This doesn't have the normal 1 unit distance between each point, so I want to think about the table here. So 0, 1, and 4. So when I plug in 0 into the square root of x, it should be 0, and then 1, and then 2. So if I look at my x values, I have a distance of 1 and then a distance of 3. So if I look at my transformed graph, from here to here, that's a distance of 1. And then from 1, it looks like it goes to 4. That's a distance of 3. So there's no horizontal dilation. But now let's look at the vertical. Distance of 1, distance of 1. If I look at this, looking at it vertically, I don't have a distance of 1 anymore. It's a distance of 3 because I'm going up 1, 2, 3. 1, 2, 3 from the starting point. And then also, if I look here, from 2 to 5, that's another distance of 3. So instead of 1 here, I'm multiplying each of these parts with 3, which is going to be a vertical dilation. So we have a vertical dilation with a factor of 3. All right, so that means our function is going to be, we have a vertical dilation of 3 times the square root of x, and then a vertical translation of -1. All right, hope this helps.